Hey, here's our first one. I'm going to do my best to make these things very useful, these videos, as to whatever types of problems you might be encountering in your online homework. I'm going to do my best to make sure that you have some examples of every type of problem, or I'm going to call them games, every different game. So here's going to be your first game. You got to know what the freaking limit is, right? So we have this new term. It's called a limit. It's what we're going to be playing around with for all through chapter 2. Well, if you're listening to this in summer or fall of 2020, be 2.2 in your textbook. We might be on a different one some other time. I don't know. So let's roll into it. Let's just look at the definition. This is going to be the first game. It's going to ask you what limits mean. But we need to be able to read this. And there's so many words. Now, this is the intuitive definition of limit. I would say of a limit, the limit, but whatever. I'm a math person. So we're just trying to get the definition. So I'm going to say let's kind of do this for now. Let's kind of just, we'll get to that. We'll get to that. That's what we care about right here. Well, the limit of f of x, the way we read this thing, the limit of f of x, as our x value gets closer and closer to whatever that a value is. Maybe it's a 3. I don't know. Then it's going to equal some y value, some number, some height. Maybe it's like 7. I don't know. That's right. It needs to be some number. Now we need to understand what it's saying with numbers and values and functions in there, because our first game is going to ask you, what does this say? It's going to give you some multiple choice. You're going to want to be able to get through this thing. So now let's start seeing these words that are going to really matter. And I'll give you some examples. We'll make sure that hopefully it makes a little bit more sense. So, okay. Now I'm going to write an example right next to it. The limit is x tends towards 4, and they'll make our function. Let's get a good function there. Maybe x squared. Okay. Wow. Sorry, my surface sucks. It makes my writing look like a 4-year-old's. Okay, there we go. So we have a function. So there was our f of x. So in this case, I'm saying that f of x is x squared. That's your function. That's a pair function. We know what the hell that thing looks like. Our a value in this case is 4. And I'm going to just let you know that this is going to equal, what's 4 squared? What's 4 squared? What happens if you plug that x in just for 4? What did you get, 16? All right, cool. I just wanted to get you some sort of an example right next to it. You know, instead of A's and L's and F of X's and shit. Because I know it was when I was a Calc 1 student, I actually took Math 30 at Sierra College with Professor Buchwald, and he kicked my ass, but he made me much better. I didn't know any of this shit. I barely knew what a function was. So it doesn't really matter where you're at right now. You can kind of start over. I see students all the time come in with some shitty algebra skills, bust their ass and make it happen. So, hey, if this is rough, none of this made sense to your teacher the first day. None of this stuff made sense to your teacher like the first few weeks. But I just hung on and kind of did my best. So a lot of this shit, it's just going to be like that. Do your best to understand our first game. So here it comes. We want to say, we need to be able to read it. So reading this here is this. The limit of the function. Now I say it a little bit differently, but this is the way your book does it and your online homework. So the limit is f of x as x approaches a equals L. Now I typically say, I say this first, this second, and then that third. I usually say it. As x approaches 4 of x squared is equal to 16. Yeah. The limit is x tends towards 4 of x squared is equal to 16. That's how I would say it. But we just want to be able to read it. Oh, I mean, the limit of f of x, not x squared. As x approaches a, not 4, right? Equals L. So you can read it I'll say it in a lot of different ways. You'll hear me say it differently. But that's not where you need to have your mind. We're trying to get to it. But here is where the game's going to come in. I looked in your homework and I saw this. It says if we can make the values of f of x is a y value. Okay, remember that? Well, how you were in algebra and all of a sudden y turned into f of x? That's y values. L is a y value. All right, so f of x It gets closer and closer to that frickin' number. So x squared, the y values get closer and closer to 16. We can get as close as we like to 16, as long as we're making sure our x is sufficiently close to a. So as long as we can get that x value close enough to 4, isn't our y value going to be close enough to 16? Heck yeah, it is. You know what I mean? You got a little parabola. I'm going to call that 4, 16 right here. Right? As the x values get closer and closer to 4, the y values get closer and closer to 16. That's what this is saying. But you're going to have to be able to answer these questions in your homework. And they love these little terms, and I'm not usually a big stickler for it, but I got to make sure you can answer your freaking homework. So arbitrarily, f of x arbitrarily close to L. X sufficiently close to the number. And these are going to be your first few questions. You got to be able to answer them. I want you to know what the hell's going on. I don't mind if I just give it to you. It's all good. It's the beginning. So let's play this game and say we have the limit as x goes to 2. And let's make our function this time 4x. So what happens if you plug in 2 in for x? You would get 8. Now it doesn't always work like this where you can just plug the number in. So I just wrote in a limit. I said the line y equals 4x. Oops, I mean f of x equals 4x. Our y values. So we could say that 4x gets, that's the f of x value. So we say arbitrarily. I'm sorry, but we got to get through it. Well, how do you spell arbitrarily? Am I doing it okay? Okay, there we go. Close to, and then what's our number? What's our L? Because this is just a game to try and make sure we know what our L is and what everything is. That's 8. When x is sufficiently close to, and then what's our a value, right? Remember this from back here, sufficiently close to, our a value is just going to be 2. And then that would be the choice. So we're going to say our f of x gets arbitrarily close to 8. Our f of x was 4x. When our x values get sufficiently close to 2. And that's kind of what's happening here. Now the way to kind of remember this stuff, when you're going, the limit is x tends towards a of some function is equal to L. Here it is. There it is. It's a nice thing. All your x values are down here. All your y values are up here. Okay? X values down below, y values up above. So we're saying, let's take the limit as x tends. That is crazy. $1,000 surface, and it can't even write. X tends towards, say, 3. And we take a function that has no domain issues. You're going to be playing with functions that have domain issues soon. We're just messing around. Let's call it 4x squared. And then let's do yeah. And that's equal to 36. So our y values is our f of x. It's our function. That's the height. The x value is the address. That's the horizontal shit. So 4x squared is equal to 36. Now y value will be 36 when our x values are close to our 3. And let's show that. Just a quick graph, you know? What the hell? I'll let you go. 4x squared. Let me just draw it. Wow. That is really, go out and spend $1,000 on the surface. It's really worth it. It's really worth it. Thank you. All right. So as our x values get closer and closer to 3, we would find out that our, this isn't even legible. All right. We're saying if we come in from we get close enough to this point here, our x values get closer and closer to that 3, our y values will get closer and closer to that 36. All right? Does that make sense? You just kind of smash it in. To get that shit close to 36, your x value better be close to 3. And that's what a limit is. A limit's all about getting close to. Here's the best example I can give you of what a limit is. Walk halfway to the wall. Then walk halfway to the wall. Just find any wall and just go up to it. Just walk halfway to it. And then walk halfway. And then walk halfway. And then you walk halfway. You'll never actually touch the wall. You get really freaking close to it, but where are you going? You're going towards the freaking wall. That's what a limit is. It doesn't necessarily, you never actually have to even get there. It's just where are you going? Nah. Hopefully some of this shit made sense. And again, I told you, your teacher, none of this made sense. None of it. No. Oh, we could quickly, before I get out of here, I lied. We could say that our function f of x gets arbitrarily, I gotta keep spelling that. You won't have to. You just have to click on the right one. To 36. And f of x is actually 4x squared. When x is sufficiently, remember, I wrote them in yellow and purple so you can see where the f of x's and the l's go together, and the x's and the x and the 3. X is sufficiently close to 3, right? From right there. Oh, there's that game again. Those will be the first couple problems in your homework. The next one, I'll show you how to do the next couple problems, and so forth.